So let's see. Craig, is Kyle back in your office yet?
I'm right here.
Ah, there you are. Okay. So agenda, we're going to talk about 4.1. Craig has some demos or some things he wants to talk about with regards to web agents. I wanted to start off though with Kyle and a backnet proxy agent issue that was discovered.
So this applies to you, Andrew. Um, so it turns out that the version of... All right, Craig's talking in my ear. Yeah, Craig's talking in my ear. Um, his problem with segmentation support in the backnet proxy. If for some reason it's not respecting the segment that setting in the proxy settings, it is not a problem with the VOLTTRON code. It is, I believe, a problem with the version of backpipes that we're using. Um, and what happens is the virtual backnet device that the proxy creates does not support segmentation, or is at least acting like it doesn't support segmentation. This was discovered earlier this week because somebody attacked it with Wireshark. Um, the assumption is that originally that when we were seeing this behavior, we thought that the devices were just misreporting their capabilities, because in the past we have successfully worked with devices that required segmentation support in order to grab the number of points off the device that we'd configured it for. Sometime in the interim, we upgraded our backpipes version, and it started causing this problem. Although we didn't see it because you have to configure a backnet driver to try and scrape more than 100 points off of the device at a time. It's somewhere between 100 and 120 is when you hit the limit. And people don't actually do that very often. And like I say, we had seen it work in the past, so we thought that it was a problem with the user's devices. Uh, like I say, if someone went at it with Wireshark and figured out that the backnet proxy was not even trying to send the request, which means that the proxy is the problem. So the workaround right now is to use the max per request setting, available both in the UI and when you configure a backnet device. If the device you're communicating with is capable enough, it will a setting of 100 should be optimal. Because that is approximately how many points you can request in a single message with the default message size that the proxy is set for. And most nice higher end devices will support a message size that it's either as big or larger. So if you're seeing this problem, the first thing I would do is set your max per request setting to 100, and that should fix it. Unfortunately, you can't just update to the latest version of backpipes. A couple of versions have come out since the version that we're using now. Backpipes API has changed, and it will break the proxy if you try it. So don't do that. It is on our to-do list to update the proxy to support newer versions, and it'll probably end up requiring newer versions of backpipes. But it will not make it into the 4.1 release because we don't have the available staff to work through it and feel like we can get adequate testing done before the release. Yeah, and in some cases you're going to have to set it, like Craig says, you're going to have to set it less than 100. If the device that you're trying to communicate with has better capabilities than what the proxy has by default, 100 should work. That's all I've got.
Okay. Thanks, Kyle. Let's see. We also wanted to give Andrew some time to demo. So Craig, why don't you talk about? Okay, yeah, that works. Let's make sure. I want to make sure to highlight research done by other people. So, Andrew, do you want to take it away? Assuming he's there.
Sorry, I did find my window. Sure.
Oh, your audio is really quiet.
Is it really still really quiet?
Yeah, it's still pretty quiet.
Let's see here. Maybe I should just yell. Does that help?
Yeah, we can
Uh,
hear you if you.
okay, so I'm not yelling that loud. I'm just speaking loudly. All right. So let me do my little screen share here. Some folks were asking in Slack about the CrateDB integration that Craig had been working on, or actually they were asking about dashboarding. I was very comfortable coming into to VOLTTRON, golly. I've been working till like 1 a.m. with Craig every night this week, so that's if I'm not talking, then that's why.
Oh, it's been fun.
So, so I was familiar and very comfortable with a dashboarding app called Grafana, and so one of my goals was to get the data from VOLTTRON in some format that Grafana can consume, and one of the things that kind of had come up was that there was this CrateDB that was a larger community-supported database that was designed for machine metrics and kind of tackling this space that VOLTTRON seemed to be in, so I thought it was a natural fit for there to be a driver for it. Craig thought so too, or at least enough to put some work into a driver. And then this week, I took his driver and modified it some to support essentially the query API in Crate that Grafana uses. So I was going to look at that here just to show folks. Craig had basically built and was using Crate as a SQL database and had kind of recreated the SQL schema that I think had been used before with VOLTTRON. Crate has a lot of features that I don't fully understand, but using it as a SQL database wasn't how the Grafana API was using it, and so therefore what I did was I added a function here that is called from the config to enable what I called a raw schema. So it just writes in parallel to your conventional schema that Craig put together, and it uses some really cool features in Crate to do things like it takes your topic, and that becomes just a field in your data, not a separate index for the topics. But it also creates a topic underscore FT, which in this case means full text. And what that does is it takes every time you write a piece of data, the database breaks it up into tokens that are searchable based on patterns you can pass it. So most of our paths have either are delimited either by forward slashes or underscores. So basically what this does is it takes whatever the topic is and breaks it up into a document that then you can search for any of the text in that document based on these. And this pattern is not regex for what you want to search on, it's regex for the delimiters that you want to break the incoming text up with. And then obviously we're just storing timestamp. The other thing I didn't do was implement any sort of text storage. This is just for values because I don't have any way of graphing text anyway, so I didn't really care about that. What that looks like in CrateDB, I'll just show you real quick. That field is invisible here. It's not part of the schema. It's kind of internal. But when you run a query against it, you can do things like where, and then instead of having to say like use regex to do this search, I just use the topic underscore FT equal. And it also converts everything to lowercase when it does that. So all your queries go against lowercase. Bam. How's that for demo? A whole SQL command with no syntax error. It's a new personal best.
Nice.
So anyway, you can see that because there was a white space between room and temp, it was parsed as temp, and I was able to pull it up using an equals, not using any sort of regex. So in this case, when you have one of these full text indexed fields, you're actually checking that this value exists in any of the fields. So what that looks like in Grafana is over here. Grafana has, I would say, modest support for query building in Crate. It's still pretty manual, but I'm actually going in here. I'm saying this looks really weird because I'm saying where topic underscore ft equals temp and where topic underscore ft also equals room. Obviously, it can't be temp and room at the same time, but it's actually just saying where temp in topic ft and room in topic ft. And in this case, I just wanted to look at this device, which there isn't another device on there right now, so that was probably a waste of a query. But I am you'd still use regex even on that to say, of those tokens, give me the ones that start with average, or don't give me the ones that start with average, I'm sorry. And then you can group by the original topic string, so that's what I get here is each value based on that topic. So that is a way to get VOLTTRON data into a pretty dynamic dashboarding solution. And one of the cool things about Grafana is the ability, obviously, the last time I dropped tables is this morning, so I don't have a whole lot of data to look at here. But we can look at, say, the last 6 hours, and if there's something interesting going on, Grafana has really nice features like click and drag to zoom into a time period, like that. So, and obviously higher frequency data would be more interesting in this, but you can do this on a week's worth of data or a month's worth of data as well. I think that's pretty much all. I think Nigel was who was most interested in that, so hopefully that was what he was looking to see.
Yeah, thanks a lot, Andrew. Can you hear me?
Yeah.
Yeah, that looks great. Just got a couple questions. So, I mean, configuring the aesthetic of the graphs is probably just something that you can easily do.
Sure,
like
yeah.
Having a white background and stuff like that?
Yep, all
Okay.
that, yeah.
The other question I had, which I posted on Slack yesterday, was about the VOLTTRON name. So if you have your VOLTTRON name that's a bit more readable, you might want to use that to
Sure.
find them. Is that available in the database? I'm just sort of getting started.
So I think that's things that we need to talk about. So I just I went to actually a conference about Grafana late last year and met some of the folks at Crate then. That's how I found out they had the Grafana driver.
Mm-hmm.
And actually arranged for one of their guys from Berlin, who's going to be in the U.S. in a couple of weeks, to come by and speak to one of our developer meetups where I'm at.
Okay.
And so I was planning on waylaying him and asking some better questions. I don't think I know enough to create an effective schema that is fully optimized and accomplishes the things you're talking about.
Well, this is just the topic name, right?
Right. But
Yeah.
that's what I'm saying. So like this, I added what I needed to add to the schema to make it work with Grafana in the meantime.
Yeah,
I think
and
there's
it's
like at some point we'll land on like a really robust schema, and I think one of the things would be like a nice name field, because obviously if the data's there, we could group by it, but it's just not there right now.
Yeah, I mean, this is the most flexible solution right now, and I think it's great. It's just the name is so long.
Sure, yeah.
If you're trying to like,
it's not very readable.
So I know Splunk pretty well, And if Grafana or the solution that Andrew is showing is anything like Splunk, you can have like mid lookup tables that you can take these long names and basically condense them into another lookup result, which you then graph as part of the graph.
Yeah, and that's functionality that would be in the driver for Grafana, and I don't think the crate driver for Grafana is quite there yet in maturity level.
Yeah. So like in Splunk, you just do a CSV file and then you basically look up a key in it and get the short name.
Yep. No, I'm familiar. And then, but now one of the cool things Grafana does do that would work here is we can look up template variables. And if you wanted to say define some template variables that you used, you could do that, but it's not quite as dynamic as say as putting together a Splunk dashboard or something. Just because again, this driver's only been around for a few months for Grafana, so
yeah. Well, I'd be looking at something that our engineers could use to produce some. I guess the industry name would be a multi-trend on a system, and then save that view, let's say, right? And then come back a few months later and be able to just click on something and look at it again with updated data. That's something that you couldn't even do with Trender, right? Can you do this with Grafana?
I mean,
like save views and stuff like that?
So yeah, so here's my dashboard list. I only have one that has crate data in it right now. The rest of this is populated from Prometheus, which is another time series database.
Yeah.
And I'm actually working on building a historian for Prometheus as well.
Mm-hmm.
It won't be suitable for like the one true source data for whatever you're doing. Like if you're doing machine learning or something, you wouldn't probably want to rely on Prometheus as your database. But for getting human interactable visualization out of your infrastructure, I think it's probably ideal, and it has all the support for the naming stuff like you're talking about. So in that case, you store each trend as a say you would have temps. And then the on that temp trend, you would have a tag for the building, all those things. So it gets into some of the tagging space that we talk about in industry on the industry side, but it supports it very robustly. And I'll show you what that looks like over. I'm just going to ignore that because I don't want to save the changes to the data. So this one, you can see that in here. I have renamed these queries would normally show up here. That's basically what the crate data, driver is doing, and I'm renaming them here. But I can also do things like any tag that is on that piece of data after it's been selected. I can template out here. So now you see that I pull out the address of the instance into the graph. So you could simply tag everything with what you wanted on it, and then be able to access that and compose it in Grafana.
Oh, that's cool.
And then this is a template tag, so I'll show you real quick how templating works here. So this just gets all the list of hosts that are in my AWS that have been configured for metric scraping, and that becomes this $ instance, which is a template tag I can use throughout my queries, so that there's a list at the top for somebody just to click the one they want to look at, and it'll go off and run all the queries again based on that template tag.
Oh, that's great. Yeah, I think that's kind of what I was looking for, right?
And then this is our actual. Then the other thing I'll show off real quick. Wasn't really intending this to be a Grafana demo, but since you ask questions, you get answers. So the other thing Grafana does is provides a visual alert configuration engine. So you can see up here there's this tag that I can actually drag around to set alert thresholds. And once those fire off, there's a number of different handlers that are built into Grafana, one of which is the Slack connector, which I'm using here. So I'll get, I can show this to you real quick too. if something happens that goes over that alert, I will not only get a notification, I'll get a snapshot of the graph at the time that happened.
Okay, that's
So,
cool. That's really neat.
And you also get a snapshot when it returns to normal. So.
Oh, cool. Thanks for showing that stuff off. I'll be interested to see when, is this driver that you're working on with Craig something that once you're happy with it, will be shared into the VOLTTRON somehow, or we can talk about that?
So it actually got merged today, the ability to fire off this raw schema, which is what Grafana is using. So if you wanted to start playing with it today, you could. I just wouldn't recommend on relying on it as part of your business process until, like I said, we've had some time to get people more knowledgeable than I involved in the schema.
That's great, because we're setting up the simulator environment with some VMs to do VOLTTRON testing, so you can just put it on there.
Sure.
And maybe I'll want to reach out to you and Craig to help me get that set up, sort of like what you've got. I think that's about it. We can move on to whatever else that the guys wanted to talk about. I guess just one last thing would be, when I searched up Grafana, there was some recent discussion about another solution called Kibana and this elk stack. Have you heard of these things?
Yeah, so here's my Kibana instance. Kibana is an elk, or basically an open source version of Splunk that Bora was referring to.
Okay.
So it's more along the lines of parsing and indexing unstructured data like log files, or semi-structured data, I should say. The beauty is that it can take you can define structured data, and it will give you all the niceties that you get with structured data, but it'll also give you when something comes into it that it doesn't recognize, instead of saying I don't recognize that, it still lets you search against it and do all those nice things. It's not really designed for numeric metric data, so that's kind of how I visualize the difference here, is that metric or time series metrics are what we're really dealing with when we talk about trends.
Mm-hmm.
And Kibana is not really, you can certainly abuse it and do it that way, but it's not the right tool for the job.
So you think that the CrateDB as a backend for Grafana, you've probably put a lot of thought into that. That's a good solution, other than like Influx or Elasticsearch?
So Crate is actually on top of Elasticsearch.
Oh, okay.
But I wouldn't say that that's like the end-all answer. I think that's been a lot of discussion that I've been involved with Jeremy and the folks there, but I'm sure they've been having with other folks too. I don't know. I honestly don't have like a recommendation for what I think the best thing is. What I do know is that Craig started a Crate driver and I jumped on it. So.
Okay.
Yeah, that's kind of pretty much it. Yeah.
Okay. Well.
Blame Craig.
No, you can blame Andrew. He's the one who did the last pull request.
So this is a case where something we were doing already dovetailed nicely with what Andrew is trying to do.
Well, I'm sure that you guys have put a lot of thought into it. Then you wouldn't. Now you're putting a lot of time into it, so
yeah,
that's good. Well, yeah. Thanks for that demo.
I think it's more that we're expanding our universe and trying to include as many people in it as possible so that this moves forward. And this integration that Andrew has shown, he's got one of the larger clusters that we've been able to play with. So that's been a big help in providing the community stuff. So.
Great. Yeah, we're going to be, we've been working with Terry at Intellimation for a while now and trying to collaborate on stuff. So now we can, at SES in Vancouver and Victoria, we can start scaling up and contributing to this work. So yeah, it seems like it's getting towards more of a critical mass.
We hope so. Okay, so what's next, Jeremy? Is that me?
I think that's you.
Okay, so what I've got for show and tell today is I'm basically going to show the start, because I didn't actually finish it, but the start of a creation of a web application on top of VOLTTRON. With VOLTTRON, the web services layer or the web layer allows pretty easy integration just to serve static files if you need to, or to reach into an agent and do an RPC function such as what VOLTTRON Central does. So that's what I'm going to show here, if this works. So all right. So everybody see my desktop? Let's just verify that that works. You can see it? Okay, good. So what I've got here is just my basic VirtualBox environment, and I'm going to put both of these into the root, and I've got a VOLTTRON environment already bootstrapped up. So we'll activate the environment and throw that over there. And then what we'll do is we'll just start VOLTTRON here. And one of the things that we require in order to have the web be enabled, and you can put this in your configuration file for VOLTTRON, or you can do it on the command line, but you pass bind web address, and you can pass it any local or exposed Ethernet address or web address here. I'm actually going to use zeros because I want to be fancy today. So that what this will do, this will bind it on any IP address that's known on this system will bind to port 8080. And if I spell VOLTTRON right, that would help. So this basically started up everything that's running, and it started it just in this one window. So if I control C, it's going to die, which is good, and we see that it unregistered the route. And if we look at the log messages here, we can see that, and I've got this web agent in the background that will go, but it tells us that we're starting the web server using this binding. It's using the specific agent that it's using because I have this running as an enabled agent, which means it's going to automatically start when the platform starts up. The identity here is web agent, and then we have the registration of the different endpoints. And right now, what I've got is I'm registering a JSON RPC route. I'm also registering a WebSocket endpoint, and then I'm registering a static endpoint, which would give us everything else. And that's going to be serving out of this directory right here. So if we open our browser up and we go localhost 8080, and this is the static web server. I know it's really exciting, but this is being served by our small agent. And so what we can do to verify that it's live is we come in here to our index page, and we can see let's make a modification here. Let's add a header here. H1, this is a big improvement, and I will make this a little bit better when I'm finally done with it, but there we go. We have some live data coming on as we go. And the most important part of this is the agent code. And so this is the agent code that we have in order to facilitate this, and this will be out on before the 4.0 or 4.1 release, which should happen next week. This example agent will be out there, so you can use it to as a template for your starting your web-enabled agents. So the big parts of this, the most important parts of this are number one, passing enabled web into your agent constructor. You can do this either here or all the way down in the VIP main, the call to VIP main. And what that does is enable the web subsystem to be present within the VIP namespace. Without it, the web service is not enabled on this agent. This is very similar to the config store, passing config store equal true, or I don't remember what it was, use config equal true to the constructor to enable it. But then there's three methods that are used on that web subsystem off of the VIP namespace. You have register endpoint. That allows you to register an exported JSON RPC or whatever CGI, whatever kind of method you want to put on the end of that, as long as it has this signature, you can post to it or get to it, and it will call the method. For WebSockets, there's a register WebSocket method, and behind the scenes we use WS for Pi, and that is how we allow WebSockets through the Python infrastructure. With WebSockets, there is a notion that it should have some authentication. In VOLTTRON Central, we use a session mechanism that allows the specific instance connected to a specific user logged in with a session token. We embed that inside the WebSocket topic or WebSocket endpoint, and that's how we can, because we're behind HTTPS, we can do that, and then all of the communications going through a secure socket, and therefore we can have distinct endpoints per user, per logged in user, so that responses only go back to that client. But for right here, and we use I use this open WebSocket endpoint to essentially validate that this user or this endpoint is allowed from a specific IP range. I add the endpoint and then I return true. If I had returned false, then the WebSocket connection would be closed and it wouldn't have ever opened. So the client would get an error on the call. Then there's also events for closing WebSockets as well as receiving WebSockets, and the one thing that I didn't is do a send, but what we can do after, no, I guess I did, because no, I didn't. So if we wanted to like add an echo response, we could go self dot WebSocket endpoint and what is the I think it's send data, but I will figure that out because I used it before. So and since I was up late last night and didn't quite finish what I needed to do, I will show this off again later, but it's going to be out on the web. I'll show the rest of this actually working. But in the meantime, what we can do that shows the WebSockets off is I gotta start it up. Hold on just a second. This is what I get for doing this ad hoc. So with Chrome, it has a very, it's pretty cool network tools available out of the box. And because I didn't open it before I connected, it doesn't show them. But now we have this management WebSocket, and this is data that's coming all the way back in from one of the VOLTTRON central platform agents, and it's bubbling up all the way to the web UI. So we can look at our performance data that we've got going on here is, what the heck are we storing? So this isn't quite as up to date, but we have our heating and cooling, and there's something wrong with my agent, so that's okay. But these are topics that are being sent all the way up through the stack back out to the client. So you can subscribe to, and as I said in the earlier point, I'm subscribed to the management WebSocket, which is /VCWS, and then this is the session key for this user, for this logged in user. And if I go back and log in a different time, and now this is my new session token, and this one should not receive data any longer because my endpoint is no longer connected. So we have the, even though my username's still admin, I've logged in two different sessions, and so I only get the responses that I need. Okay, any questions?
All right. did you want to discuss 4.1?
Yeah, we can discuss 4.1. 4.1 is getting very near completion. I will be branching off the 4.1 into the releases. Oh, so yes, they do. Sorry, but there's a question. Do router endpoints support parameters? And yes, the parameters are all wrapped up within this data argument. And that's, so you have the environmental variables for the server, and then the data will hold the parameters that were sent in through the either through the JSON RPC method. Basically, the data will end up being this the JSON data argument. Okay.
Hey, Craig.
Yes,
This is
sir.
Bob. Sorry. But I guess what I meant was on the URL. So I'm thinking. So I'm going to follow. I'm going to use this. I'm glad I tuned in because I plan to use this for our step 2.
Yeah, I figured that, and that's actually one of the reasons that I wrote it.
Thank you.
Because it's a much simpler thing than VOLTTRON Central. So
Yeah.
and it shows the power, and I'd rather have people use this than roll their own, you know?
Yeah. No, this is great. This will be great. So, but one of the requirements we have is that, like, for the endpoints, for the URL, those, there are going to be device IDs and indices, list index parameters in the URL itself.
So you're talking like you may have at this equals that blah equals blah or something like that. Is that what you mean, or
no,
is it encoded differently?
Actually encoded in the URL, like a RESTful URL that
So like
an object
this
ID.
driver is foo, or whatever,
Yes.
where driver is foo. And
Yeah.
Parameterized. So currently, that string you could tokenize it. You'll get the URL in the environment, and that's
Okay.
part of the path. So yeah,
So I would just pull it out.
You would have to do it. You just pull it out. Yeah.
Okay.
That's not something that I have done. That sounds like a good idea, but it's not something that I'm going to do right away.
Okay.
But if you create something and it's generic enough, that would be awesome to add that back.
Okay. Cool. Thanks.
Okay. Yeah. So 4.1. There's a lot of stuff that's changed. There's a lot of improvements have made to VOLTTRON Central. We have verified that we can scrape devices with 6,000 points. Although painful, it will do it. I did it with two buildings of that size yesterday, and so it does work. It's actually easier to. It's actually more. The UI responds better once the data is there, so you can edit it much easier than you can initially scraping it. But that's where it is. We have a new Crate Historian. There's been some big updates to the Mongo Historian. There's a whole bunch of different documentation that's been added. We've updated to a new backnet or backpipes libraries. We've upgraded to some newer, a new version of ZMQ. We're not at the latest, but we're continuing to update that. There's been movement on different applications in the VOLTTRON-applications repository. There's been a lot of changes that really shouldn't impact a lot of people, other than in order to take advantage of things, you're going to have to rebuild the platform and or rebuild your agents that are deployed. Which begs the question, one of the things that that there is in Python Bootstrap is if you want to, for example, install the dependencies for Crate, you can use our Bootstrap script to do that. And like right now, I just installed the Crate driver using Bootstrap Crate. And if you see, we've added different extra packages that we are either thinking of using or using. And there's the Mongo, MySQL, Pandas. If you want to install all our databases, you can use the -- databases, and it'll pull down the latest package for each of those as well. And this actually isn't. That was more than what I actually wanted to talk about, that because that's actually been in for a while, but I figured I'd highlight it. Anything else, Jeremy, that you can think of? We've got BACnet driver updates that have happened. Oh, one other thing. All of the different agents now have a .version, the RPC function that you can call through the VIP.version function, so that we are attempting to increment versions as new stuff comes out. Like you can see that VOLTTRON Central here at 4.1 will be a 4.0 release. The BACnet was point increased because there was an argument added, and it now uses multi-point get by default. Did I say that right, Kyle? Multi-point get. The BACnet driver, multi-point scrape or whatever. Anyways, never mind. Doesn't matter. Multi-property get. Yeah. Read properties. All right. Yeah.
One of those.
Okay. Go ahead, Jeremy.
No, I was say, and then something that's not in 4.1 but will be coming soon is the improved message bus.
Yeah, and that will be 100%. Did we decide that it was going to be 100% backward compatible or not?
Right, because the issue was that you would need to upgrade everything at one time, but
right.
put the shim in there to make it so you didn't have to do that.
Right. Yeah, so you don't have to rebuild your entire infrastructure to gain the benefits on a VOLTTRON Central node or whatever.
Yep.
Yes, that's coming. That's not in 4.1 though.
And what was the speed increase on that?
I think it was upwards of 50%.
Yeah, it's quite significant.
30 to 50, I can't remember. It's right in there.
Yeah, quite significant improvement in the speed of the message bus, which especially matters in cases where you're trying to send a lot of messages very quickly. So that'll be a nice addition. Not in 4.1 because we wanted to make sure that we tested out internally before we release it, but that should be coming soon.
Yeah, before September.
Before September, yep. All right.
Anything else?
I think that hits the main ones. Then there's some additional examples and things like the MQTT Historian that
that's right.
Mike demoed last week. I feel like Chandrika added some things. There's a few other examples and improvements and things like that. But those were the main things. All right. Did anyone, we got about 9 minutes left. Anyone have any questions or any topics that they wanted to discuss?
Or if they have topics that they want to discuss for next week, that would be good to know too. Or not next week, 2 weeks.
Yeah, Bob's got a slot next week, right, Bob?
Yeah, this is Rob Calvert from Casensum. I'm hoping to get some of that time.
Yep. And then anybody else who wants time, let me know.
This is Nigel from SES. I just had a question about the latest updates, or at least something that Craig talked about earlier when that he did recently was grab or scrape 6,000 points. Was that from a whole building, like various devices?
That was from a single device.
Wow.
And when you're talking scrape, you're talking for the device configuration UI, right?
Yeah, I'm talking for the device configuration.
That means in the CSV registry file there were 6,000 points?
There were at the beginning, and then I filtered it down
okay.
through the UI. I filtered it down to all of the temperature sensors, basically, which ended up being like 150. I think it ended up being like 200 points or something like that. And with the Jace, because this was with the Jace, I think it was the Jace. I'm not exactly sure. Andrew could probably tell me that.
Okay.
It was really it's a slow responder for some reason. I don't know, but so we had to turn the max per request down to like 25 to make it work when in the actual master driver functions.
So my question is, when you are subscribing to, let's say, 1,000 points in a building, and you're configuring your device driver with an interval, right? I think it's like somebody mentioned 0.08 or seconds.
That's really fast. 0.08, and generally all the stuff that we do around here at PNNL is on a 60-second interval. And
sorry, I meant like it's the interval per point. Like, okay, I want to take all this 1,000 points from a building.
Sure, and you want to distribute it across, right?
Well, let's say I want to take data at 5-minute intervals, right? And
sure.
I want all that data, all those points scraped in a short amount of time as possible, so that I can say that they were all done at 0, at 5 minutes, at 10 minutes. So my question is, how much is the spread on that collection of those 1,000 points?
Can you answer that, Kyle?
I'm sorry, what was the question?
So does the spread? So our interval's 5-minute interval.
Mm-hmm.
Does the driver automatically spread it out so that it goes the entire time?
No.
It does as fast as possible?
No, there is a global setting for the amount of time between each scrape. And so what you do is you tune that for what your network can handle, and then as you add more devices, it spreads it out over a longer period of time.
Yeah, that's what I was wondering. So that is a number that you can configure, which I was saying is about I've seen a number like 0.08. I can't remember what field.
But it's like is it? Are you seeing it in the? Yeah, 0.05.
Yeah, and so we're getting a point every 0.05 seconds, right?
You're getting a device every 0.05 seconds.
Okay, that answers my question.
Yeah, and typically you're going to try and do depending on your devices, you're going to get them all in a single read multiple request. So unless it needs to be broken up over multiple read multiple requests, it's the number of devices per second is probably the best metric that we can think of to tune it by.
Okay.
And they would tune it by looking at the log and seeing if it can handle it or not?
Yeah.
Okay, so like if I want 5-minute interval data over like thousands of points, I would...
It's the number of devices.
Yeah, that's going to tell you...
Yeah, so if you have 50 devices and you want to spread it out over 25 seconds, you would do 0.5.
And now the number of points per device, though, that was that earlier conversation about 100, right?
Yeah.
Okay.
That's the current. Well, yeah, that's kind of your high watermark for how many devices per request you're going to get. Even if there wasn't for the segmentation bug, if it does support segmentation, the proxy still has to send multiple, will have to divide that request up itself automatically.
Yeah, and I think when you do filter, like Craig said, to down to the points that you actually want to subscribe to,
Mm-hmm.
it would rarely exceed 100.
Yeah.
In my experience. So.
Right. And if you have a device if you have like a physical device that has, like, say 6,000 points on it, we can't hear you, Craig.
Mute myself. Okay, so on the UI here, we have
It's a good thing you're my office mate, man.
Yeah, exactly. The max per request, what we had to do on the Intellimation is we actually had to put this down to 25 because 100 was too much. Here we can do it at 100 because, well, we've got three points and our devices are really fast and our network's really fast. But we can turn this up to like probably less than 10 seconds, and it would scrape, and you'd see all this stuff happen right over here. But the question I'm wondering is that exposed? What Nigel's talking about, is that exposed here? It's not, is it?
No, because it's a global setting in the master driver.
Right. Okay, that's why. Okay.
Yeah. Currently, it's not in the UI.
Yeah. Oh, so it's a setting. It's not a per device setting.
No, it is not a per device setting.
Okay. That's where you set the interval, like.
Yeah.
That you want.
Yeah, and like I say, it's based on, if you did have a device that had 6,000 points or something like that. Typically, what you're going to do in practice is break it up into logical devices. So you're going to point your driver. You're going to point multiple drivers at the physical device, and each one's going to grab a piece of that thing based on, the actual stuff in your HVAC system that it actually corresponds to. And since the setting is basically a global setting for how it tells the drivers when to scrape, you could spread that one physical device over logical devices, and then spread out the scraping of that device into smaller requests just by virtue of the fact that you've broken it into logical drivers. You've broken it into logical devices by setting up multiple drivers. Does that make sense?
Sure.
Okay.
I mean, I don't think I have to deal with that problem.
Yeah.
So, but when I do.
Well, there's something we're dealing with right now has 6,200 registers on it, and so there's probably going to be a push to divide that up into logical devices just so it's easier to work with. I'm not sure if that's on the Intellimation stuff or where that is. So, okay, somebody's typing up a question. The upper limit on points per logic, it's the same as physical device. Right now, the upper limit. Okay. So there's no hard and fast rule for it. It's more of a you have a physical device that has 6,000 points on it, but like 20 of those points represent an HVAC or a variable air volume controller or something like that. And so we're talking more about dividing it up based on what those points actually represent. There's no upper limit, but in practical terms, probably, 200 or 300 points. But the system will support as many points on a device as you want, as long as you turn up the timeout value in the BACnet device. You can actually turn it up to several minutes, and if it takes it that long for the proxy to acquire all the points that was asked of it in the first place. Yeah, we just made that configurable through the UI too. There might actually be some configuration that we need to make available in the proxy, but we'll discuss that we'll discuss that later. Currently, because you have to divide it up anyway with this manual setting, it doesn't matter how long the internal timeouts on the proxy don't really affect it.
So just the last question here.
Sure.
It's 12:01, but
I'm turning into a pumpkin.
No, it's beer time. No.
It is
it's
Friday.
lunchtime. About the UI, so do you anticipate that for this 4.1 release next week that it'll be at the stage where the backnet discovery and some of these other things you're talking about will be there?
Yeah, they are
Okay.
there. They're actually in develop now.
Okay.
I'm actually comfortable with I'm reasonably comfortable. I mean, we're still lab software, but you know,
Yeah.
I'm reasonably comfortable with the results that I've gotten over the last week and this effort that I've done. So yeah, I just finished. There's a couple other things that need to get put back in. There's starting and stopping of agents that need to get put back in so that works correctly. But other than that, I think that the discovery of points and device configuration, I think, is pretty solid.
Great. Thanks.
Yeah, the bug in the backnet proxy that requires us to use the max per request setting, that the fix for that will not make it into 4.1 just because of the amount of testing that's going to be necessary to make sure that everything works.
And unless your stuff can actually scrape the points, the UI will fail. So there is that. Ha!
All right. All right. Well, thanks everybody for calling in, and we will see you in 2 weeks. If you have any topics you'd like to discuss or anything you'd like to present, just go ahead and email us, and we'll make that happen.
Hey, Jeremy.
Yep.
Did we ever get a finalized date for the next meeting?
No.
I can't remember what it's called.
Technical meeting? No. There's
technical meeting. There you go.
Nope, there's no final date set for that yet.
Okay.
Okay.
Just thought I'd see.
Yep.
All right.
All right. Thanks. Bye.
Okay. Bye.
Thanks, guys.